Okay. So we think we got it. So we think we've set this up right so all the transitions happen.
Yep.
Then we have to make our what's called our discrete Markov process. That's how. Oh, I should probably change this to the process abracadabra, but that's okay for now. We know what it means. Now let's take a look at the graph, which is going to have, instead of 8 states, 12 states?
Yep.
Yeah.
And we see the absorbing state there at the end.
Yep.
Let's bring this up. What do you notice that's different about this graph? So just tell me some things you think are different about it.
Well, there's sort of this triangle right here. ABR can go to ABRA. This is like a triangle here. That's sort of different, but not really that different.
All right.
I mean, maybe this is just because the graph's set up this way, but there's like this, almost like this line out from ABRACAD.
Okay. What does that near line mean?
Well, that's just the path that you could take to get from ABRACAD to abracadabra.
Okay. Now with the Covifi process, gotta change that 8 to a 12. We had 7 letters, and it took 26 to the 7th.
Yeah.
Okay. So here we have 11 letters. So before we run the process, here's what 26 to the 11th is.
So 3
It's a lot.
million, billion, trillion. So 3 quadrillion.
3 quadrillion, 3.67 quadrillion.
Yeah.
So my first guess that I want you to take is the abracadabra going to be more or less or equal to 26 to the 11th?
It's gonna be less.
How come?
Well, because 26 to the 11th is like, it's for only 8 states. You had a number in like, I think you had it in the billions, but this is in the quadrillions. It's way higher.
Okay.
I think you're going to be a little bit less.
All right. What do you think?
I think less because there's less opportunities to sort of just start over here, because sometimes if you get an A, you actually keep going instead of start over.
Okay.
So I think it'll be less because of that.
All right. So let's see what the stopping time is here.
Almost identical.
6, 7, 4, 8, 7. So it's actually a little bit more.
It's bigger by about 1 million.
Huh.
But it's actually really close.
It's actually really close to 26 to the 11th, but the surprising thing is it's larger than 26 to the 11th.
So this might be a good approximation for it if you're doing it for other numbers.
It's a good approximation, but the difference is interesting. So the prior entry minus this is
43700.
It's actually about 500,000.
okay. Now let me show you something. I'll show you what 26 to the 4th is.
That's interesting.
So it's close to, or very.
How close?
It's 36. No, 26 away.
So the answer we got turned out to be 26 to the 11th
Minus 20.
plus,
plus.
minus 26 to the 4th minus 26. I need to run this again and then subtract away 26 to the 11th. I'm subtracting away 26 to the 11th plus 26 to the 4th plus 26. You see what I mean? And I get 0.
Cool. Cool.
So for abracadabra, the expected stopping time is not 26 to the 11th. It's 26 to the 11th plus 26 to the 4th plus 26. Gosh, sorry for turning the screen like that.
That's.
So what do you think? Why do you think it's longer?
Well,
Well, it's a bigger word than Covifi,
Yeah.
but it's only, Covifi was 7, this is only 11, but it grows really fast.
Yeah, it does.
So, It's gonna have something to do with these exponents here because it equals that exactly once you do it. The exponents.
Yeah, it does equal it exactly. Why do you think it's different? Why do you think it wasn't exactly 26 to the 11th?
Well, I think because of the overlap, because we didn't experience any overlap with Kovifi.
Uh-huh.
Because like we had some overlap between the states, like we had paths that we didn't have before.
Right, we had paths that we didn't have before.
Yeah.
So that's probably why it's not exact.
But it's interesting. So we did it. We did it really carefully. And yeah, we got this really surprising answer.
Yeah.
So this is cool. This is a really fun problem. All right, good work, guys.